Good day everyone. Let's look at this other problem on surface area from Maths 6. It says calculate the surface area generated when the arc x squared equal to 4y between y equal to 0 and y equal to 4 is rotated about the y-axis. So you see, I picked out all the important items. The first one is the equation. Then the limit will give you how your formula ends. The rotation tells you how your formula starts. Then you go to your formula sheet, you look for that formula. So based on this information, we are doing a rotation about the y-axis. So my formula must be starting with ay. Then my limit in terms of y. So my formula must be ending with dy. Then I will look through my formula sheet and search for that formula. So that formula for Maths N6 is on page number 7. So I'm seeing a formula that starts with ay and ends with dy, and this is how it reads. The integral from g to c 2 pi x, the square root of 1 plus dx over dy, all that square dy. So that's how simple it is to pick the correct formula. So once you pick the correct formula, it then guides you through the whole process. So you can now start looking for dx on dy. So to do that, we need to write down our function. Our function is x squared is equal to 4y. So we're looking for dx dy. So the way it is written, I can apply N5 knowledge to do implicit differentiation, then make dx dy the subject, or I can make x the subject first, then I calculate dx dy. So I'll try to take you through both methods. So if I start with implicit differentiation, it means I'm differentiating both sides. So if I differentiate x, I'll get 2x, then dx over dy. So that's how implicit differentiation works. Then if I go here, I will differentiate, because with dx dy, you're differentiating y. If you differentiate y, you get a 4. So from here, if you make dx dy the subject, dx over dy, it means you are dividing both sides by 2x. That will give you 4 on 2x, which becomes 2 over x. And after that, you can do the squaring. You get dx over dy, all that square. Why am I squaring? The formula says so. It means I'm squaring 2 over x, which gives me 4 on x squared. But here you must be careful to see that your formula ends with dy, which means we don't need any x in here. Even this x will have to look for its meaning later. So that therefore means if you do the squaring of your derivative, you get x squared. You must go back to the original equation and see the meaning of x squared. So this reduces to 4 over 4y, which is simply 1 over y. So that's where dx over dy, all that square. So you see how we handle it, and we make sure that everything that is going there must be in terms of y. So that is option 1 of getting your dx over dy. So let's look at option 2 of getting dx over dy. So another person could have started by saying that I will make x the subject, since I'm looking for dx over dy. So to make x the subject, I start by taking the square root. If I take the square root of both sides, this will be the square root of 4y. And don't forget, the square root covers 2 items there, which are multiplied. So that means it's the square root of 4 times the square root of y, which gives me 2y to the power half. Then from here, I can get my dx over dy. You know you don't differentiate a constant, so I'll write 2 first. If I differentiate y, I'll get 1 over 2, because I need to bring the power in front. Then I subtract 1 from the power, so that will give me negative a half. And this becomes y to the power negative a half. And we know very well from our N4 that when you are done with differentiation, sorry, I'm now putting dy over dx. When we're done with differentiation, we don't leave answers with negative exponent. So if I make the exponent positive, this is 1 on y to the power half. Then from here, you can now square our term. So if you get dx over dy, all that square, it means you are taking 1 on y to the power half, all that square. If you square 1, it stays as 1. If you square y to the power half, it means you are like multiplying y to the power half by itself. That is the meaning of squaring, and the base is the same, so you add the exponent. A half plus a half gives you 1. So it means at the denominator we are left with y. So you see, whichever method you use, then you end at the same level. This side we got 1 over y, this side we're still having 1 over y. So that was just to show you the different options of looking for dx dy when your function is different like that. So now that we know dx dy, the next thing is to look at dx dy, all that squared plus 1, as the formula says. So we get 1 plus dx over dy, all that square will simply mean 1. 1 is the same thing as 1 over 1 plus 1 over y. So you see we got 1 over y there. So if I move on and take the LCD, my LCD means I multiply the numbers at the denominator, that will be y. Then I take y divided by 1, it's y times y is y. Then y divided by itself is 1 times 1, it's 1. So that is what we get. So I believe we can now bring the whole formula that we copied from our formula sheet, the integral from c to d of 2 pi x, then the square root of 1 plus dx over dy, or that square dy. So that's our formula. We start by appreciating the fact that 2 pi it's not in terms of y, so that's a constant. We take it out. Our c and d are the limit, 0 and 4. The smaller person down there, the bigger one up. Then x cannot be there because the active variable is y. So in that case, it's either you look for the value of x and then you bring it there, and to look for the value of x, you see, if you follow the second method, you know the value of x already. If you follow the first one, then you will just take the square root of both sides. So you can see the value of x as 2y to the power half. So in the place of x, I'm putting 2y to the power half. Then under the square root, I'm putting y plus 1 over y dy. So one thing we know about square root is that the square root cannot move over addition, but it can flow over division and multiplication. You see that here, the square root can move over multiplication. That's why the square root of 4y was the square root of 4, and the square root of y, since 4y means 4 multiplied by y. It will also move that way over division, but over addition, it will get stuck. 2 is a constant, it moves out. So I'm now having 4 pi out, the integral from 0 to 4. So I'm left with y to the power half, which is the same thing as y, multiplied by the root of y plus 1, then divided by the root of y, since the square root can move freely over division as well as over multiplication. So this now helps me take care of that one. So what I'm left with is just 4 pi, the integral from 0 to 4 of y plus 1, all this to the power a half. So this is a simple U substitution, which for NCEET students, there is a formula we use for that in page number 4 to make you move faster. We give it the name the power rule, which is written like this: the integral of f of y to the power n multiplied by its derivative dy is equal to f of y to the power n plus 1 divided by n plus 1 plus c. So as an NCEET student, once you see a problem like that with the power rule that has a power, you start thinking of the power rule. If you don't have the energy of saying let u be equal to y plus 1, you look for du dy, you can also do that option, it's not a problem. So we'll try to pass it through the power rule, and this is how we do that. We get our 4 pi, the integral, then we capture the formula. The formula is like that. In the place of f of y, I will put in the item that is supposed to be my u, which should be y plus 1. Then I have the power there. Then the formula says you multiply by the derivative of the person in here, and if you differentiate y plus 1, you get 1. Then you attach your dy. Then you have to compare what is here with what is there. If you look at the two, you see that they are exactly the same. There is no difference. But if there was some little difference, then we would need a number outside to balance it out. So now that there is no difference, it means I will now use the right side to write my answer. where I capture my f again and I add 1 to the power. So now as my answer, I'll be having y plus 1. If the power increases by 1, as the formula is saying, you get 3 over 2 divided by 3 over 2 from 0 to 4. So what we've done is what a student would also have said, let u be equal to y plus 1, you look for du dy, you go and integrate, and then you get your answer, you return the u, you replace u by the value of u, so you still get there. So at this stage, we are now at putting our limit. Our upper limit is a 4, that's what we'll substitute first. So I'll get 4 pi in bracket. If I put 4 there, 4 plus 1 is a 5. So I have 5 to the power 3 over 2 divided by 3 over 2. Then I start the process again. I get my 4 pi and then substitute the lower limit, which is a 0. If I get 0 there, I will be getting 1 left to the power 3 over 2. 1 to any power stays the same. Then I divide by 3 over 2. So what is left is for us to talk to the calculator to hear what it says about that calculation. So what I will simply be doing, considering the fact that 4 pi is common, I'll just do this calculation minus that one, and I'll multiply my answer by 4 pi. So let's go. I've got 5 to the exponent. 3 over 2 is the same thing as 1 comma 5. Then I divide by 1 comma 5, which is 3 over 2. Then minus 1 on 3 over 2 is the same thing as 2 on 3. So that subtraction gives me 6,786. Then I will multiply my answer by 4 pi. And that gives me 85,287. So guys, that's how simple it is for our surface area. We get 85,287 unit square. So this was a short one. And thank you very much, because we've come to the end of that problem.